Hello, class. Today's lesson is going to look very similar to our last lesson, except for with a small little twist. So today we are working on multiplying and dividing rational expressions. And that is our objective, that we come out today being able to do those operations on these new kind of expressions that we've talked about. So before we start, we're going to warm up. And we're going to recall what we know about fractions. So the first question says, circle all the expressions that are equivalent to 12 over 24. So remember, equivalent means equal in value of any way. So take a moment. All right, let's see. Did you circle them? Well, 12 over 24, if you do 4 times 3, that's 12, and 6 times 4, that's 24. That's an equivalent expression. Here, 3, 6, well, 12 over 24, if I divide 12 by 4 and 24 by 4, I do get a 3 over 6, so that's equivalent. And 12 over 24, if I divide 12 by 12, I get 1, and if I divide 24 by 12, I get 1/2. So these are all equivalent to 12 over 24, but they all look different. These are different in the way we reduced. And this one was actually kind of like before 12 over 24 happened. So it's the multiplication of two fractions that ended up giving us that. All right, so now we have another one. This time we have some x and y's. It's a monomial over a monomial instead of a number over a number. I want you to circle all the expressions equivalent to this expression. Take a moment. All right, let's see how you did. Well, if you look, if I multiply the tops, I get 3xy, and if I multiply the bottoms, I get x squared, y squared, which is the same. So this is equivalent. If I said x and I see an x squared on the bottom, that's there and there. I see a 3, that's there. But the y's seem to have disappeared here. But y and y squared, I should have a y on the bottom, so this isn't equivalent. Here I have a 3 on top, and I have my x's. Okay, so x squared and x, that should have an x on the bottom, but I should technically have a y left on the bottom as well to make this equivalent. So this was the only one that was equivalent. We did this just to think about how to rewrite multiplication in fractions in general, because again, rational expressions are polynomial fractions. So now that our minds are spinning, we're going to talk about how to multiply rational expressions. So the first step to every problem is the same first step as the other day, and that is to factor everything. Factor! I told you it keeps on coming back. And to multiply fractions, we are just rewriting the tops together and rewriting the bottoms together. So to multiply fractions, we know that we can just combine tops with tops and bottoms with bottoms. That is so not math termy, but you'll see how easy that is. And after we combine, it'll look exactly like the regular simplifying expression lesson we did. So then we get to eliminate. And we can't forget our restrictions before reducing, before that elimination stage. So let's see this in action, because it's not much different than our last lesson. So if we look at number 1, remember this is just asking us to reduce and state the domain. So the first step is to factor everything. So over here, we need an n plus 9, n plus 9. The bottom is a monomial, so we don't have to factor it. The top is a monomial, so we don't have to factor it. The bottom we can factor out as 7 and get an n plus a 9. Because this is multiplication, we just have to multiply the tops all together and the bottoms all together. So I could technically just extend this and just say, all right, this is 10n squared times n plus 9 times n plus 9. And this is 10n squared times 7 times an n plus 9. So these are all just together. We're extending that bar. So now it looks like just a top and bottom. Remember, we can restrict only the bottoms. So we're going to say what n can't equal. And in this case, n can't equal 0. And from this case, n can't equal -9. And then we get to eliminate the same things. Remember, it's got to be a top-bottom elimination. So here there's an n plus 9. That gets rid of that n plus 9. Here is a 10n squared. Here's a 10n squared. So what I'm left with after eliminating is n plus 9 over 7. So again, the only difference of multiplying these from our last lesson is extending that bar and just getting more factors to deal with. Because remember, the definition of factors are terms multiplied by each other. So over here, these are multiplied by each other, and then we're just adding more some multiplying. We're going to do number 3. We're not going to do many of the multiplying ones because it's very similar to our last lesson. So the first step is to factor everything we can factor. So I'm going to factor this guy. I'm going to see if I can factor this guy, factor this guy, factor this guy. So this first one, it looks like I can take out a GCF of 8x squared, making an x left and a -1 because I took out that whole thing. The bottom is just 4, so that doesn't help. Here I have an x squared plus 5x minus 24, so that's an x times an x, factors of -24, that give me 5. Negative, so there's 12 and 2, that's not going to work. 6 and 4, that's not going to work. 3 and 8, so positive 8 minus 3. And this bottom one can be factored as well. That's an x minus 3, x minus 1. Again, it's multiplication, so I can kind of just take that multiplication and extend this bar and say it's this times this times this times this. And on the bottom, it's this times this times this. I need to restrict, so I'm working with x. I'm only looking at the bottom. There's no x attached to this 4, so there's no restrictions needed because it's restrictions on x. Here, x can't equal 3. Here, x can't equal positive 1. Now I'm going to eliminate what I can eliminate top and bottom wise. So on the top over here, I have an x minus 1, goodbye. Bottom, goodbye. An x minus 3 on top and bottom here and here, goodbye. And then I have some monomial stuff going on here. So 8 divided by 4. So the 4 gets to go away and the 8 becomes a 2. That's just regular fraction math. So everyone that's left is a 2x squared x plus 8. There's nothing on the bottom. I could write all over 1, but we don't have to write over 1. 1 only has to show up in the top if we needed it. So that's it, fully reduced, and there's my restrictions. I really enjoy the elimination stage. I think it's fun. I'm going to do one more multiplying. That's going to be number 6. So we're going to factor everything we can factor. So 4x squared, there's nothing to be done there. We have a 12x cubed minus an 8x squared. I could take out a x squared for sure. And I could take out a 4. So that leaves me with 3x minus 2. Multiplied by, okay, here, definitely some GCF here. I could take out a 5x, leaving me with a 3x minus 2 on top, and 8x. Remember, it's multiplication, so it's really just saying all these guys multiplied by each other, all these guys multiplied by each other. Remember, these are all monomials, so those operate a little bit different. They can be separated from each other. These guys cannot. We have to find the exact binomial to cross out. Before we do any crossing out, we have to do our restrictions of what x can't equal in the denominator. So here for 4x squared, if x was 0, that would be really bad. We get 0 on the bottom. For 3x minus 2, that's a factor, so its 0 is 2 over 3. And again, this one is a 0, so we already wrote that down. So we're good with the restrictions. Now it's my favorite stage of elimination. This is the same exact thing as this. And now we're left with all monomials, so we can kind of just cross out anything we want. Well, this is a 4x squared, so these definitely can go away. This is a 5x and an 8x. They're not attached by addition or subtraction, so I can actually just select the x's to cross out. And I'm left with 5 over 8, and that is the fully reduced version for number 6. We're going to change it up, and it's only going to be changed up a tad. We're going to work with dividing now. So before we start dividing, I do want to do some side fraction math. So back in the day, around 4th grade, when you were told to do 1/4 divided by 1/3, you may remember this or not, you were told some kind of mnemonic to keep, change, and flip. KCF, not to be mistaken by KFC, the fast food chain. And that means that you kept the first fraction as is. You changed the sign to multiplication, and then you flipped the next fraction. And then you were working with multiplication. The same rule of 4th grade goes for the same rule now. If we see division, we are going to keep, change, flip, so then we rewrite it as a multiplication problem. And then just do exactly what we did on the previous page. So again here, the first step to every one of these is going to be to factor before we do any keep, changing, and flipping. To divide fractions, that's when we are going to keep, change, flip. So keep, change, flip. And again, that means keep the first, change the sign, and flip the second fraction. Then we're going to be able to eliminate from there because it's just a multiplication problem. Eliminate. I definitely spelled that wrong. Yeah, there's an I here. I'm losing my mind, guys. Sorry. The only issue we have to address is we need an additional set of restrictions. Since we are dividing by the second fraction, we can't divide by 0. That means none of the second fraction can equal 0, the numerator or denominator. And so we need to list our restrictions before reducing. So that's saying this whole time, this guy stays as a numerator, or a denominator. So we're going to restrict him. This guy stays as a numerator. There's no restrictions on him. But at the beginning, this is a denominator, so we have to restrict. But then when we flip it, this becomes a denominator, so we have to restrict. So we end up having to restrict all 3 of these spots when we see the division sign. So we have to remember that in our restrictions. So we're going to do this example. The first thing is to factor, no matter what the sign is. So we're going to factor everything. Here we can factor out a 21. So we have an n plus 2. Over here we have an n times an n negative 10 plus 1. Keeping the division sign because we haven't done anything yet about that. Over here We're going to factor out a 21 again, and an n plus 2 is left. Here we can factor out an n and a 9. Oh, we can factor out an n squared and a 9, leaving me with n minus 10. So I'm going to do my restrictions now, because I know I need to do here, here, and then eventually we're going to flip, so I also have to do here. So I'm restricting all of these guys. So n can't equal 10, negative 1, 0. That's 10 again, and that's a negative 2. Note I didn't have to restrict the top of it here. So now I'm going to keep, change, flip. So I keep the first set of things. I change the sign to multiplication, and then I flip the numerator and denominator in the second one. And because it's multiplication, I can treat this as one long line over one long line for my elimination stage. Some things to note. You could restrict here or here, just as long as you know you're doing this spot, and this spot. So that means you can keep, change, flip first or not, doesn't matter. Now when you go to eliminate, everything's good because we're at the multiplication stage. You're going to eliminate tops and bottoms again. So this guy goes and this guy goes. This guy can go and this guy can go. And this one can go and this one can go, leaving 9n squared over n plus 1 left. Honestly, after crossing out so many things, some of the biggest mistakes I see is just when you go to find the survivors, people leave things out. So just be very meticulous when you do that. So again, one small change from what we did, and that's the keep, change, flip for division. Then it turned into multiplication from what we just learned. And in multiplication, all it really is treating it as simplifying rationals from our previous lesson. So not too heavy on actual new material, just some little changes here and there. So we're only going to do 3 and 5 more. The next one, first thing we do is factor. So we got to factor a whole bunch of things out. So we look here, and we see that we could take out an 8 and an m squared, leaving us with an m and a 42 divided by 8. Oh, 42 is not divided by 8, so 42 is not divided by 4. I could take out a 2, leaving me with a 4 and, or a 21. The bottom is simple factoring, m, factors of 60 that give me 4, and it's negative. So I could do 6 and 10, where it's a negative 10, positive 4, divided by, okay, this is still 8m squared. This is m minus 10 m plus 1. I'm going to restrict right now my m, so I have to look here, here, and here, because remember, eventually I'm going to flip this. So that's a 10, negative 4, that's a 10. I already wrote that down though, so negative 1 for this one, and right here I have a 0. Now I'm going to keep, change, flip. So keep this one. Change the sign to multiplication, and then flip numerator and denominator for the next one. And again, this is multiplication, so I can extend that bar. It's all these tops multiplied by each other and all these bottoms multiply each other. So now I can start eliminating. I see an m minus 10, m minus 10. I see an m squared, and everything else is not reducible. So I have a 2, a 4m plus 21, and an m plus 1. And then I have an 8 and an m plus 4. I realize that I can actually reduce the 2 and the 8, so the 2 goes away and the 8 becomes a 4. And there's my final answer. We're going to do number 5 as well. 5 just looks a little sloppy, but really it's not, because this is just 1, 2 rational functions divided by each other. So I can rewrite it as this with my division just looking differently. Because remember, there's like 12 different division signs. One's a fraction bar, one's this division, one's a slash. Once I have it rewritten like this, then it looks like the same ones above, and we can follow the same steps by factoring. Here I'm factoring out a GCF of 2x. So I'm left with x plus 9 with the 2x. Division, x minus 3. So this is factorable as x minus 3x plus 9. I'm going to restrict. Remember, I have to restrict here, here, and here. So x can't equal 0 from this one, negative 9 from this one, 3 from this one, negative 9 from this one, but I already wrote it down, and 3 from this one, but I already wrote it down. So now we're going to keep, change, flip. So keep, change the sign of multiplication, and flip. Because it's multiplication, remember, I can just extend that sign, and it's all of this multiplied by all of this. And I'm going to eliminate. So bam, 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 bam. I seem to be left with a 1 over 2x. So to see if you understood this lesson, here's the ticket to leave. I want you to do everything we were doing before. I do want you to note that one thing is a little different. So actually, I do not want you to do this ticket to leave. Never mind. It was in your document. Just ignore it for today. And now you're going to continue on with today's agenda.